Hello everyone. Good morning, afternoon, or evening. Dear authors and invited guests, welcome to Technical Session 12G. My name is Alesha Mullah, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026, in Bangkok, Thailand. The 11th edition of this conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, and the virtual event is being held from 9th to 11th April via Zoom. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 10 presentations. Each presenter will be given 10 minutes to present and 2 minutes for question and answer. On the 9-minute mark, I will raise a gentle reminder. There is another request to all the participants. Please stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Before we start the session, I would like to introduce the chairs. Dr. Iosef Gabilea is an associate professor at Kauna Kolegia Institute of Higher Education in Lithuania. A multidisciplinary expert in marketing, digital transformation, and leadership, he brings over 15 years of experience in academia and business management. His research focuses on AI in marketing, digital and vital brand engagement, process optimization, e-learning, corporate training, and sustainable development. Welcome, sir. I would request you to please say a few words.
Yeah, thank you so much for introductions and good evening, I think. Good evening to everyone. It's a very early morning for me, but I'm really excited to be here and definitely looking forward to hear all the presentations. I have opportunity to check few of them, and I just want to wish everybody good luck and let's have some good time here. Thank you.
Thank you, sir. Our next chair for today is Dr. Minaki Raut. Dr. Minaki Raut is an associate professor in the School of Computer Engineering at Kalinga Institute of Industrial Technology in Odisha, India, with over 20 years of experience in teaching and research. Her areas of expertise include data science, machine learning, and generative AI, with active contributions to academic excellence, research, and student mentoring. I would like to request ma'am to please say a few words.
Thank you, Alicia, for the introduction. Okay, and all the best to all the participants to present their research paper. As Alicia has already given the instructions on how to forward for the presentation. So please stick to the time. And once again, all the best. And I also like to welcome Dr. Josep Cavalier as professor. Thank you to be the session chair of the same session over here. I am Associate Professor Dr. Minaki Raut. Here it is in the kit. And we can proceed, Alicia. Thank you, everyone.
Thank you, ma'am. Without any further ado, let's begin with the presentations. Our first presentation is by C.R. Ananya, who will be presenting a usability evaluation of a mixed reality cooking assistant. You may now begin your presentation. Is Ananya in the meeting?
I think there is a request in the chat for them to go a little bit later.
All right. Okay, no worries. In that case, we shall move on to the next presentation. All right. So the next presenter for today will be Dinesh O. Shirsat, who will be presenting adaptive sparse reconstruction of ECG signals using fast independent component analysis. You may now begin your presentation. Is Dinesh present? All right. Dinesh, you're not audible.
Yeah, hello. Am I audible now?
Yes, we can hear you.
Should I continue?
Yes, you may.
Yeah, thank you.
Dinesh, I believe you're muted again.
Am I audible now?
Yes, you are.
Hello.
Yes, you are.
Yeah. Presentation topic: Adopt response reconstruction of ECG signal using fast competitive independent analysis. Like under the guidance of Dr. S. V. Sampar. I'm from basically from Maharashtra, India. So these are the few topics. Another topic about the context here.
Dinesh, I'm so sorry to interrupt. We can hear you, but your voice is, it's really not that audible. How could you try speaking up and a little bit clearer, please?
Just a second, Mike. Hello. Am I audible now?
Yes, much better.
Okay. So the introduction what is the clinical diagnosis related with the heart disease considered. But these are often distorted by the ECG signal, baseline wonder, or EMG activity, and the electrode motion related with that. So considering that effective denoising must reduce this whatever the non-stationary noise that have been present, and these are very important because we have to look at morphology where we can get that affected with heart or related disease, and that is with the EQRS. So for this, we are going to I'm going to consider that as an hybrid approach in order to denoise or whatever the noise that has been present in the ECG signal. So this work proposes like a two-stage technique, like using blind source separation, and another is what selective noise elimination by using the through sparse approximation. Meaning is that we whatever the smaller content of the noise is that is been like it has been reduced to that is the zero, so that we can get the clean that is the signal. So the key strength we are talking about here, so be the blind source separation. It simplifies or whatever the mixtures by disentangle the sources, means separate the sources. And while the space coding provides a precise control over which the signal components can be retained. So this is the literature survey that have been gone through up till now, which is from 20 to 2025, which had gone through all this and gap with that. For like it was 2020 that methodology survey on deep learning methods for ECG denoising and classification was there, and it was focuses on taxonomy but lacks implementation level of improvement or the hybrid optimization is being considered. Then another was related with the clinical evaluation of denoised ECG for what you can say the rhythm interpretation. So it does not propose a new denoising algorithm as such, and it was limited to that is the evaluation. Like that up to 20 like a 20 to 21 that is what the literature survey I had done up to last that's 2025. So if you talk about that last one, it is LSTM plus DCGN hybrid for long ECG signal. Here it was like training instability was being observed and high resource was the requirement. So from the literature review, it was observed that deep learning models no doubt provide good performance, but suffer from considering high complexity and data dependency is what the main aspect. So while classical methods which have been there lack the adaptability, means these are not adaptable to what the signal condition it is. So because in order to denoise that is the so our method, that is the fast ICA with the sparse approximation, it provides a balanced solution, and by achieving what can I say the high denoising performance with lower computational complexity, and with main important is the signal preservation that we are going to look of that. So here research gap when you're talking here, like there are like a lot of things. Insufficient real pair data sets are there, cross device generalizations are there, then clinical validation is also very important, that is which is seems to be the one of that. Then robustness to rare pathologies means here ensuring denoisers which are being there preserve the pathological features, which has been very important. For example, the S or and the T changes means these are the features where the actually the ECG signal we can say like PQRST. So and under that it is going to be changing with that they are saying like heavy noise is been the remaining challenge under the evaluation. Then also one more part, that is safety and regulatory readiness means standards for certifying denoising algorithms is also a very important, that is the part needs to be development. What is the research? And the next part is research novelty and key contributions. So here the core innovation is that a unique hybrid cascade framework that integrates the what can say the statistical separation power by using that is the fast component analysis, and with signal refinement is being obtained by using adaptive spares reconstructions. By combination of this is what my work it is there. Then you can see a synergic two-stage denoising is what the thing is first part. So usually the existing method rely purely on statistical separation, which is one of that is the component analysis, or purely transforming domain filterings are there. So our contribution as far as this method is there, we are using the fast independent component analysis, and means to first do what you can say disentangle with the mixed noise sources, which is a very that is what we are going to distract that. Followed by that will be followed by a sparse approximation stage to surgically what is that remove some residual noise which are from within the isolated cardiac components, because cardiac components are what the wanted part for the analysis or can say for the classification. Then another is the accelerated convergence is what is being utilized via fast iterative soft thresholding, that is the algorithm, and this is for the sparse recovery. So your novelty is like unlike what you can the standard ISTA is there or pursuit methods are there. This FISTA provides convergence rate, which is very important. That is what the finding here, making the sparse reconstruction phase variable for real-time ECG that is monitoring is being considered without that is the high latency. Then another is that is the feature preservation is also important as far as adaptive thresholding is there. So like instead of a static threshold, our work employs and that is adaptive shrinkage, that is the model. Means depending upon the signal how it is vary, that thresholding will be applied and the noise will be removed from this. So what will be the benefit is that this ensures that whatever the low amplitudes are there, but clinically you have vital features in that. Like as we know, there's a P wave and T wave are very important. That is the feature with that. So these seems to be the preserved by using that is the adapt, even though we are using the adaptive thresholding. While the high frequency, which are the EMG noise, and low frequency baseline wonder are seems to be suppressed, which are seems to be forming as a part of that is the noise. And here, so the superior performance matrix is like validation, that means we are like we have achieved a peak signal to noise ratio and correlation coefficient up to like 0.993 that exceeds the traditional discrete wavelet that is the transform method, and the statistical independent component analysis that what means better than that what we have been used this both as far as hybrid cascade framework we have been that using fast ICA and the adaptive sparse reconstruction is there. So here the impact is the error rate in QRS detection is been like reduced by 3.1% directly, and it's improving the reliability of the automated heart rate variability, and as far as HRV analysis being considered. And this is what the problem and the proposed solution for this. The problem is conventional filters as bandpass filter, wavelet shrinkage are underperforming as far as dealing with the complex mixed noise, which is the main aspect as far as my presentation is being considered. Because we need to look at the clinically important, significant, that is the features with that. So here the research gap is existing deep learning models have been suffering from high computational combine already I've told in the literature survey as and data dependency. While the classical method there's talking about that it has been lacking the adaptability. So for this, the solution is we have used a pipeline combining the fast independent component analysis for the source separation, and this sparse reconstruction is there for refinement. So with this
I'm
method,
so
as far
sorry
as
to
the
interrupt.
proposed method.
Hello, I'm so
Hello,
sorry
yeah,
to
ma'am.
interrupt. You have 1 minute left.
Yeah, ma'am.
You have 1 minute left.
Yeah, ma'am. I will go to. Yes, yes, ma'am. So this is what the problem formulation as far as mathematical model is there. As far as the previous we have been considered. So we have assumed that is x of t is equal to a of s of t plus n of t, and accordingly the reconstruction is being done. So this is the methodology where the input is ECG signal is being taken with the fast independent component analysis followed by sparse approximation and then reconstruction, and then the signal is being filtered where the clinically important parameters are being kept without any problem or damage done to that. Then this is what the comparison related with the ISTA and FIST, okay, implemented. So average iterations 48. So as you can, computation time it is 0.021 compared to ISTA, and even reconstruction on error is 0.042. And this accelerated is what the for okay, the convergence time related with the FISTA seems to be good here. Then talking about this, the graphical you can see here, same way, which is being more important here. This is the experimental results. Basically, this is a ACG signal with baseline wonder, and this is nothing but the noise. So this is what I have taken a filtered signal, original and the filtered signal I have got after experimentation. And this is what the performance comparison of different ECG denoising, that is the methods. And you can see here that is the output signal to noise ratio for the proposed fast independent component analysis plus sparse approximation. It is around about 26.87 compared to other which have been the traditional whatever the denoising methods have been there. And as you can observe here, okay, and that is the other, that is the parameters MAC or RMAC. This seems to be the improvised one. And if you're talking about the correlation coefficient, it is 0.993 compared to what the other methods have been considered. So a high SNR, less reconstruction error is there, better morphology preservation, that is 0.093 is what. So proposed method outperforms your DWT or principal component analysis or independent component analysis is there. So overall, whatever the work is there, it has been improvised one compared to the other, that is the methods or that are being employed as far as denoising is being considered. And the main is that the ECG morphology seems to be preserved very accurately. And as far as processing time is also, you can see it's 0.021 second compared to the other, that is the denoising methods have been there. So this is what the table. Dataset MITBH arithmetic database seems to be
Excuse
used.
me.
Yes, ma'am.
I'm so sorry, you're over time.
Yes, ma'am. Yes, ma'am. I have done with that. This is the conclusion. Fast ICN plus sparse like approximation effectively denoises, ECG maintains signal quality and morphology improves accuracy and efficiency, and it's been suitable for real-time cardiac analysis with the future scope here. Integration with deep learning models is what the next part I'm going to do with that. These are few references that have been considered. Thank you. Hello. Hello, ma'am.
Okay.
Yes, do any of the chairs have any questions?
Yeah.
Hello, ma'am.
Yeah.
Questions?
Thank you, Dinesh, for the presentation.
Thank you, ma'am.
Regarding the slide preparation and all that, I can say it has to be uniform because you can
Okay, ma'am. Okay.
see in one slide the font size is different, the font color is different, in another slide also it is being different. So it has to
Okay.
be uniform throughout the presentation, first of all.
Okay. I will take care next time, ma'am.
And second is that in the technical point of view, in the introduction you told there are a lot of limitations of the deep learning is there, whereas
Yeah.
the statistical learning has the adaptability. But in
Yeah.
the
Yeah.
presentation, I didn't find any of the deep learning technique that you have used and compared with your adaptability of
Yeah.
statistical learning. So I'm just
Actually,
missing that part.
okay. That part actually, ma'am, like as I said, like fast and sparse is that actually problem formulation. It is there in this particular one slide. Problem formulation. It is there means whatever that separation of the mixing of the noise is there. All that it has been put up because of the time constraint. I was not able to go through that.
Okay. Whatever presentation you have done in that
Yeah.
nowhere, it is being compared with the deep learning. So my point is that ki in the initial introduction, why you have taken to tell that the deep learning has lot of limitations, complexity and all that, and
Yeah.
you
Yeah.
have done this one. You may
Yeah.
present your work, or no problem in that. You have done
Yeah.
some nobilities also. Okay. But while
Mm.
you are telling that the deep learning is having this much of limitation, and but in the presentation, nowhere it is mapping with that. I'm just
Okay.
missing. I'm just telling that this point is missing. So
Yeah.
rather you focus on the work that you have done instead of that you are misleading that deep learning has this much of limitation and it has some
Mm.
other technique has some the adaptability. Okay.
Okay, ma'am.
And
Yeah.
the second point is that that you told you have compared your proposed model with the DWT, PC, and ICM. But
Yeah. Yeah.
in the presentation, also, if it is with better, if you have shown these comparison with these three techniques in tabular form, so it is be quite
Table of form.
a tabular form. So you know that whenever it is visibility in point of view here or here it is there DWT, PC, and ICM. Okay,
Okay.
it's there then. Okay, I thought it is missing. I just in the presentation.
Yeah, it's
I
there,
do.
ma'am.
Okay, no problem. Well and good.
Yeah.
From my side, these are the questions. And just
Yeah. Yeah.
hand over to the Professor Cavalier. If he has any question, he may please go.
Yes, my question will be, you stated you identified 5 research gaps in the literature, and then you
Yeah,
made a
sir.
statement that there is one. So and what did you base your research gap to explore and study this research?
Uh, uh, yeah, sir. So actually, what is this? As my my research topic is a deep feature analysis of ECG signal and the multi-heart disease
Mhm.
detection. So this is the part, the first part that is the denoising actually.
Okay.
Denoising that whatever that is ECG signal there. After this, actually, I have used the deep learning model that is LSTM, and that is what I will be using that, and is on the way, sir.
Okay.
That's
Yeah, so
yeah, yeah.
because it was a little bit confusing, so you want to make sure that you connect them so
Yes,
that
sir.
when you explain your research, it connects the dots and it also then collects to the conclusion because kind of quickly glancing the conclusion that you showed, it's not matching it. So make sure that there is a links that connects your identified problem, how you connect it, and then how you provide the recommendations, because you want to make sure that the results are not vague. Okay?
Okay, sir. Okay.
All right. But other than that, good presentation.
Thank you, sir. Thank you very much.
All right, so now we'll move on to the next presentation. Next up, we will have Arya Sagar Sanavde, who will be presenting AI/ML powered crop yield prediction system. Arya, you may now begin. Is Arya or any of her teammates present in the meeting? right, so in that case, we will move on to the next presenter. Next, we will have Anjan Babu Ji, who will be presenting an agentic AI-based framework for crop production analysis using agroclimatic and soil parameters. Anjan, you may now begin. Is Anjan or any of his co-authors present today?
Yeah, my co-author is there, who is going to come. Hello.
Yes, could you please speak up?
Yes, my co-author is there, who is going to present.
I'm sorry, Anjan, you are not audible actually. Could you please repeat that? Okay, I think we'll move on to the next presentation. So next we will be moving on to Suman Kumar Mandal, who will be presenting early blindness stage diagnosis using a fully connected neural network architecture. Suman, you may now begin.
He will be joining in a minute now. Please allow the next presenter to present. After that, he will join them.
All right, okay. Is Suman or any of his co-authors present today? All right. So in that case, we shall move on to the next presentation. Next, we'll have S. Jayaraj, who will be presenting Ensemble Deep Learning for Rapid and Accurate Diagnosis of Neurodegenerative Diseases. You may now begin your presentation.
Okay, I want to share my screen. Is it audible? Am I audible?
Yes, you are audible. Please go ahead.
I'm checking for to. Okay. Is it viewing?
Yes, it is visible.
Oh, good evening, everyone. My name is Jairaj from Sri Venkateswara University, Tirupati, Andhra Pradesh, India. First of all, thank you for giving opportunity to present my paper, an ensemble deep learning for rapid and accurate diagnosis of neurodegenerative diseases. Neurodegenerative diseases are, yeah?
If possible, put it in the slideshow mode.
Full?
Slideshow mode.
Okay.
Yes, but please go ahead.
Okay. Neurodegenerative diseases are increasingly becoming a major global health issue. One of the biggest challenges is achieving early and accurate diagnosis, which often depends heavily on the experience of radiologists. To address this, we use AI-based computer diagnostic system. In particular, convolutional neural networks are applied for medical image classification, although they often struggle with limited data availability. In this study, we utilize advanced architectures such as RESNet, MobileNet, and VG16. We then propose an ensemble model that combines these approaches to improve overall performance. Our result shows that this combined model significantly enhances diagnostics, accuracy, and speed, ultimately supporting clinicians in making better and faster decisions and helping reduce the global impact of neurodegenerative disease. In introduction, The human nervous system is extremely complex, and the brain acts as the central controller for all major physical and cognitive functions. Because of this complexity, even small abnormalities can have serious consequences. These disorders can mainly be divided into two categories. One, neurodegenerative disease, and next one is the brain tumors. In neurodegenerative diseases are like Alzheimer's, Parkinson, and Huntington's disease. Brain tumors which involve abnormal and uncontrolled cell growth in the brain. MRI or magnetic resonance imaging is the most widely used technique for detecting brain abnormalities. However, interpreting MRI scans is quite complex and usually depends heavily on expert radiologists. Although deep learning, especially CNNs, has shown promising results, there are still challenges such as limited labeled data, loss of spatial information in deeper layers, and sensitivity to variations in brain structures. To address these challenges, we propose an ensemble deep learning approach that combines MobileNet, RESNet, and VGG16. This helps improve feature extraction and ultimately increasing classification accuracy. This is the literature review. In this, Ramya Mohan focused on compared CNN model with VGG16 for tumor classification. I found this research gap is need for higher accuracy and robustness. In coming to Nuran, focused on combined multiple CNN models, improved accuracy and generalization. Here, the research gap I found loss of spatial features in deep networks. Muhammad focused on compared with RESNet, VG16, and Inception V3. These three are compared here, but the gap is single models may not generalize well. Most existing works rely on single models. To address these challenges, there is a need for more robust approaches. In our work, we propose an NSML model that combines multiple CNN architecture to improve accuracy and reliability in brain disease diagnosis. Coming to the methodology, we take brain image data set with glioma, meningioma, pituitary, and normal for classifying neurodegenerative diseases. Next one is apply pre-processing. That means cleaning the data, resizing the images, and noise reduction. Then apply 3 deep learning models individually that are MobileNet, RESNet, and VGG16. After that, applied proposed NSML models, then compared these all algorithms with each other. Then finally classify these neurodegenerative diseases. Data set for this for our experiments, we used publicly available MRI brain tumor data sets from Kaggle. This was retrieved from kaggle.com, and the data sets consists of 4 classes: glioma, pituitary, and meningioma, and normal cases with no tumor. All images were resized to 5 by 12 by 5 by 12 pixels to maintain uniformity. MRI images were selected because they are widely used and clinically readable for brain tumor diagnosis. The methods are used here. We have used 3 well-known deep learning models: RESNet 50, VGG16, and MobileNet. First, RESNet 50 is a very deep network with 50 layers. It uses something called skip connections, which means it adds the input back to the output. This helps the model learn better and avoids problems like vanishing gradients. Next, VGG16 is a simpler and more structured model. It uses small 3 by 3 filters to extract features from images. Even though it is deep, its uniform design makes it very effective for image classification. Then we have MobileNet, which is lightweight model. It is designed to be fast and inefficient. It uses depth-wise separable convolutions, which reduce computation while still maintaining good accuracy. Finally, we combine all 3 models using NSML method with soft coding. By combining these models, we improve overall accuracy, reduce errors, and make the system more robust for brain disease classification. Now moving on to the experimental analysis. First, the data set was collected and pre-processed. This includes cleaning the data, normalizing pixel values, resizing images, and reduce noise to ensure better quality input for the models. The data set was then divided into 80% for training and testing for 20%. And all models were trained for 20 epochs. This is a model-wise analysis. First, we applied 3 deep models individually. Here, VGG16 performed well due to its simple and structured architecture. In this figure, this is the confusion matrix, shows strong diagonal values. In this figure, x-axis is predicted by the model and y-axis is actual label of the data point. In class 0, 289 correctly predicted as 0. In class 1, 289 is correctly predicted as 1. In class 2, 402 image is correctly predicted as, that is the image with exact tumor. In class 3, 299 correctly predicted as 3. For RESNet showed slightly better performance by effectively learning complex features using connections. In this figure, x-axis is predicted by the model and y-axis is actual labels of the data point. In class 0, 288 correctly predicted as 0. In class 1, 300 correctly predicted as 1. In class 2, 402 correctly predicted as 2. In class 3, 297 correctly predicted as 3. Here, the 5 instance of class 0 is predicted as class 1. 2 instance of class 0 is predicted as class 2, and 5 instance of class 0 is predicted as class 3. For final, the mobile net, it's a lightweight fast model, slightly lower accuracy compared to others. It is efficient for real-time application. In confusion matrix also, this is also the same. I find to further improve performance, I have proposed an ensemble model that combines all three using soft voting. This approach achieved the best results with an accuracy of 98.82%.
Phone number?
Performance comparison. This is a proposed ensemble model with 98.82%. It shows the high accuracy with compared to the other three models. RESNet is second best with compared to an ensemble model with accuracy of 98.17%. VGG16 is and MobileNet were slightly different in accuracy. This is the test images for compared with the trained models. In this figure, the first figure is an MRI scan of brain with a specific prediction and confidence score from classification model. This predicts of no tumor with low confidence of 55.98%.
Excuse me, I'm sorry to interrupt. You have 1 minute left.
Oh, just this figure displays an axial MRI scan of brain with prediction from classification model. The MRI scan clearly shows somewhat rounded mass located centrally at the base of the brain. The model prediction of tumor pituitary with confidence of 100%. This is a highly significant. The next one shows the prediction of the 97.62%, which is the glioma, tumor glioma. Next, there is coronal MRI scan of brain. This is the coronal MRI scan of brain. The model prediction of glioma with a confidence of 97.97% appears to be correct and made with the confidence. The next one is also a coronal MRI scan of brain. This image shows a large, somewhat heterogeneous mass located in the frontal lobe of 64.5% of confidence level. It appears to be correct, though the confidence level is moderate. This shows the model's prediction of pituitary with confidence of 97.84% with high confidence. Coming to the conclusion, among all models, the ensemble approach achieved the highest accuracy of 98.82%, outperforming individual models. RESNet also showed strong performance with the highest standalone accuracy of 98.5%. From the confusion matrix and predictions analysis, we observed high reliability overall, with only minor misclassifications. These mainly occurred between visually similar tumor types, highlighting the challenges of future overlap. Overall, the results demonstrate that ensemble deep learning models are robust and effective tools that can support radiologists in making faster, more accurate, and reliable diagnostic decisions. Thank you.
Thank you, Jaira sir, for the presentation. I have just one query over here. You have already used widely used and most popular deep learning algorithms, RSNet, VGG16, and MobileNet. It is already proved that these three are performing well in medical domain individually. Okay.
Yeah.
So what
But
my
okay.
question is, what make you think of taking all three together just to have a little difference in the accuracy of 0.8 0.8% or something like that difference is there. So what
Even
makes you take all that?
okay, even a 0.1% is also making so much difference of
In the medical diagnosis?
yes. That's why I'm using the NSML method to combine all three these. From getting output, we compare with each other.
0.01% is not at least one sample is being misclassified.
Okay.
Okay. And one more thing is that even if you have taken three deep learning model to combine, have you observed the complexity in terms of time? Because deep learning itself is taking more time to training for the one individual model. While
Okay.
here you have taken three different models.
Yes,
So it
yes.
will have been better if you have given a comparison with respect to time.
Okay, definitely.
What
That
I
next
feel
time I
so.
will. Next time I will definitely do.
Okay.
Okay. Thank you. Thank you.
From my side, this much. I just hand over to Professor Gabelia. If you have any query, please go on.
Yes, yeah, my question is actually similar to my colleague had here. It's the practical value of this work because I do agree that you have three massive deep learning models and complexity and how do we look it. So how do you see the practical value of this actually being used in the medicine?
Hello.
Because you're putting three different complex models, and then what is the practical value
Yes.
of that? What is the reasoning for that behind it?
I'm using RESNet and VGG16 and MobileNet to train the images. After getting that, I get the results from just a minute. The accuracy I want to get from exactly is RESNet is 98.17% and VG16 is 97.56% and MobileNet is 97.48%. But the NSML model gives us little bit more accuracy. That's what I am using the NSML method to get the more accuracy bit compared to the RESNet.
Okay. And then you recommend to use all three of them?
Yeah, with
Okay.
combination, the NSML method could be very
Okay.
useful to get the accuracy of the diagnosis.
All right. Yeah, so just one recommendation, make sure that you address the complexity as well. All right?
Okay.
That will make it more reasonable with the reasonings that you're doing there. Okay?
Okay. Okay.
All right. Thank you.
Okay, definitely I will. Okay, thank you.
All right. So our next presentation for today will be by Abhishek Gyaneshwar Jadhav, who will be presenting Explain ITD, an explainable, adaptive, and privacy-preserving AI framework for insider threat detection. You may now begin.
Good afternoon to the respected host and the respected session chair. I hope I'm audible. Just give me a second, I'll share my presentation and I will start immediately.
Yes, please go ahead.
Yeah, thank you very much, madam. Yeah. So our paper ID is 1350. It is Explain ITD and Explainable, Adaptive and Privacy Preserving AI Framework for Insider Threat Detection. The authors are Abhijit Jadhav, Prashant Tahire and Madhuri Hiwale. We are from Maharashtra, Pune. This is the part of the today's discussion. First, we'll try to introduce, then motivation, then we'll discuss about a few survey papers, then problem statement, research gap identified, then how explain I2D is proposed, then some overview and discussion on architecture and its techniques, and then finally result analysis with conclusion, future scope in the research. Now, to introduce basically what is the insider threat detection, or what is exactly insider threat. That is the main topic. And insider threat is when someone inside an organization misuse their legitimate access, and that can be to cause the harm. So examples can be like stealing sensitive data, or leaking confidential documents, or maybe misusing privileges. It can be anything. So basically that is the insider threat. Okay, now why insider threats are dangerous? They cause huge financial reputational losses. They are very difficult to detect because insiders look like normal users in the organization. Basically they are the normal users. And we know many famous data breaches were caused by insiders only. It is very easy to not very easy, but it is easy to detect the outsider attacks and all with the help of the hardware devices, firewall, and many intelligent detection systems. But it is very difficult to detect the insider threats, as their behavior is very close to the behavior of the normal users inside the organizations. Now, if we talk about what are the existing systems that are used, like rule-based system is there. If user downloads more than some random number of files, then alert can be raised. This can be the example. Okay, or we see some users activity that deviates from the normal patterns, then it can be identified as an anomaly. So these are the few statistical and rule-based systems available. But when we talk about this method, these are obviously powerful. Machine learning and deep learning techniques can be used. These are powerful also. But yes, if we talk about specifically machine learning, deep learning techniques, these are black box methods. Means no explanation is available how it is done, how detection is done. Okay, what is the basis for detection? If we talk about the techniques, then centralized training violates privacy also of the employees in the organization. Okay, and models degrade when the behaviors are changed. So it's a kind of concept drifting that we all know, and we will discuss that point also in the upcoming slide. So this is the simple introduction, and we are trying to say like what is insider threat and how it is important to identify the insider threat in the organization. To discuss about the survey, then we have arranged this survey based on few techniques which are already used to identify the insider threats. First, we have the rule based or statistical techniques for identifying the insider threats. Okay, now these are the key techniques where rules are used. Okay, strengths are these methods are very simple. We define the rules and get the alerts and all the things for the detection purpose. Okay, but limitations are high false positive. So false positive rate is high, and this is basically that statistics is given by Sommer and Eberle. In these two papers we have learned these things. Then supervised ML techniques like SVM, RF trees are used. They have the high accuracy in terms of known things, but the limitations are they need label data. These are the supervised techniques. Okay, and this is given by the papers in um, Alabdu Wahab and Tariq in 2023 and Kumar and Singh in 2025. Then we have also the unsupervised ML approaches for detecting the insider threat. Basically, clustering is used and density, and they find the unknown anomalies. But yes, these techniques are noise sensitive, and also their accuracies are to be verified. And we all know that about clustering. This is one of the limitation. Then deep learning techniques like RNN, LSTM, okay, autoencoder and these techniques are also used by the researchers. They have also given good presented a good research and better accuracies. Their strength is they are capturing sequences, but yes, limitations, as I said, black box, nobody knows what is happening inside for the detection. These are heavy also, as per the remarks given by Tor and Yon in 2021. Coming to the next part, few more techniques like graph based UABA, NLP based federated AI, and LLM based. Okay, so UABA is a user and entity behavior based technique. Yes, strength is change detection, but limitation is concept drift issues are there. Then in graph based techniques, graph mining GNN is a popular one, and these are used by Burley Holder and Wang and Sun. Okay, and the strengths are relational behavior, but yes, high computation as graph is involved. Then NLP based techniques are used where the sentiment analysis and is done. The strength is communication insights, but yes, privacy issues are there. Then next is federated AI, which is the strength is actually it protects data, because we are here highlighting that privacy issue. But yes, the limitation is complex deployment. And LLM based techniques are used, meta learning LLMs. These are the approaches, highly adaptive, but yes, heavy computations are involved. So these are the few things that we have highlighted, and based on that we also tried to find out some research gap. Before that, if we talk about motivation, yes, insider threats bypass perimeter security, and many organizations have already experienced this part. Their rate of detection is also having high FPR. Then existing models lack explainability, as I said, like deep learning and machine learning have that black box kind of thing. Concept drift degrades performance, and centralized AI risk privacy is also there. So we are thinking about all these things while detecting the insider threats and trying to overcome these things in our research. So now, if we talk about problem statement, the static models fail under concept drift. So when there is a change in behavior, immediately the model fails and gives the wrong predictions. And yes, it uh, ensures high false positive rate. Then single model limitations, expecting a same kind of behavior, same a single type of data is used by insider threats, is something which limits the accuracy of the model also. So single model limitations are there. We need to think about the multi-model, different various types of data used by the insider threats, lack of interpretability, and yes, need unified adaptive framework to overcome all the previous challenges that we have seen, or that research gap we have seen. Limited real world validation, lack of explainability, concept drift issues. This is what we have concluded from the literature survey. This has to be improved in the insider threat detection systems. Okay, so now let's come to the architecture of the explain ITD.
I'm so sorry to interrupt. You have 1 minute left.
Only 1 minute. Okay, quickly I'll go through the architecture. Multi-model data collection, which ensures that we are taking the type of data, logs, graph, text, and metadata. Feature fusion is there. We try to combine all the data, merge together, and generate a data vector that will be used with the short term and long term patterns that can be identified for insider attack detection. Then we have a risk scoring engine also, so which based on the behavior of the insider threat, we try to calculate its score, risk score, and then detect whether it is the insider threat or not. And to reduce the false positive, we have a human in the loop also, which ensures whether yes, it is the whatever alert generated by the system are correct or not. So that human in the loop is the analyst feedback, basically used to improve the FPR rate. We try to take it down further. So that is what the architecture we have used in our system. Now, basically, if we talk about the results, yes, the results we have observed with the explain ITD are superior as compared to the previous attempts using the statistical machine learning and deep learning techniques. We have observed the accuracy as 94.8%. Same for precision, recall F1 score and FVR. We have improved a lot with the help of this explain ITD approach because of feature fusion, multimodal data consideration, dual memory systems like short-term and long-term facts we have gathered, and also human in the loop system. These 4 to 5 parameters have made that explain ITD superior as compared to the existing approaches. To conclude, whatever explain ITD does is explainable, adaptive, privacy preserving, low false positives, and forecasting enabled. This is what we have discussed in the survey also and research gap also. Whatever the challenges we have identified, we did try to overcome the challenges with the help of explain ITT. And that black box thing is also remove adaptive because we have both short term and long term privacy preserving, as we have used that federated learning, federated AI here, low false positive because of human in loop system. Okay, and then future work, yes, real time deployment is still pending. We have tried simulated our work and we have seen the results. More modalities apart from whatever multimodal data types we have considered, logs, text, graph. Apart from that, others like email, communications, images, and all those can be considered. Self-adjusting feedback can be used to improve further, to increase the accuracy and adjust that error things. And large scale pilots, if we could do it in future, then this can be a better a major revolution in the organizations to prevent their systems from the insider threats. So that is the future work. These are the references to whom we are very much thankful. Because of their work, we could extend the research to this point. So these are the references that guided us for identifying the research gap and having explain ITD in scenario. Thank you very much. Thank you very much, host. Thank you very much, session chair, and all the participants for patient listening and giving us an opportunity to present our research. Thank you. I'm done from my side with the presentation.
Thank you, Dr. Abhijit,
Thank
for
you.
the nice presentation over here. Actually, I am listening from the very beginning that what exactly the intruder, insider, outsider, like that. Oh, you have done lot many things in a conference work, sir.
Yes, madam. Yes.
So, I have one question over here. You have written AML ITT, then DL ITT, and then you have written your proposed ITT. So, as we know, ML does not make only one algorithm. There are so many algorithms. So, here instead of writing ML, can you ever here mention the exact technique that is used over here?
Okay, madam. You are saying in result analysis?
Yes, result
Yes.
analysis.
Sorry, madam. We have not written it because of size of the table. But yes, madam, I have mentioned those all whatever RB, statistical, machine learning, deep learning, rule-based systems. I have mentioned these things in literature survey table, like which key techniques are used. If you could just be kind to go through the survey slide, madam. Rule-based techniques, rules and threshold. We have used supervised SVM,
No,
RF,
no.
and
I
trees are
got it,
being
but
selected.
like here it is written supervised ML, and here it is mentioned the technique SBM,
Yes,
RX, trees.
yes, yes.
Some of them. There are
Some
so
of
many
some of them.
supervised machine learning algorithms. So the comparison table that you have presented over here, in that comparison table, it is written ML. Right?
Yes, 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 yes. You are right, madam. Exactly right. Many of these supervised and unsupervised learnings are skipped
Yes.
actually in the presentation.
And in the yeah, exactly. And in the proposed model, you told that again you have used LSTM. That is also kind of deep learning,
Yes, madam.
isn't it? Yeah.
Yes, yes, yes,
So in the presentation table, in the resultant table, you can go to that slide, the resultant table.
yes, madam.
Here,
Ye-
you written here, na, deep learning table. They are
Yes,
not able to perform
on the accuracy 87.9, where you have used LSTM and you claiming that 94.8, which is again a deep learning technique. So, isn't it?
Yes, madam. Yes.
So in this table, it would have been better, instead of writing MLITD, you might have written the technique name.
Yeah,
because
I got it.
ML means several techniques. Deep learning means several techniques. Which technique you are talking about?
Yes,
So
madam. Yes.
only this point is missing over here, and the rest of the things, so you've done a lot of work. So what I can say in that?
Yes,
so
madam.
From my side, this much.
Thank you very much, madam, for your suggestions. I will incorporate in future presentations. But what I did is highest possible accuracy that is achieved in particular that method that is actually we have presented. So that's 87.9 is better in all deep learning techniques. That is what I did. But yes, next time I will ensure to mention specifically what are the techniques that are used in survey and comparison on the deep learning methods, machine learning methods. I will ensure it, madam. Thank you very much for your valuable.
No issue, sir. Thank you.
Madam, I am Dr. Ravi Kumar, madam.
Yes, sir.
Madam, I am audible, madam.
Yes, sir.
Okay.
Sir, it is not over yet.
Okay.
It is not over yet. Now it's just hand over to Professor Gavalia. If you have any queries, please go ahead, sir.
No, it's a good presentation. I really enjoyed your analysis. Again, no question, just a suggestion. When we talk the results analysis, make sure you connect them to the research gaps. All right, just don't leave them when you state them. Make sure it's discussed also, and then how these results are helping to understand the research gap. Okay?
Yes, sure, sir.
Because,
I'll do it.
because you post them and then I don't hear it in the discussions analysis. So it's always good to see how you connect it and then how it solves that specific research gap. Okay?
Yes, sir.
But other than that, really good work here. Really, again, looking on the techniques and results and all the data is really nicely organized and presented.
Yeah. Thank you very much, sir, for your comments, valuable comments, and I'll improve in my future presentation. Thank you. Thank you very much, host, for giving me an opportunity. Thank you.
All right. So now we move on to the next presentation. Next, we will be having Ananya CR, who will be presenting a usability evaluation of a mixed reality cooking assistant. Ananya, you may now begin.
Hi, everyone. Just a second. Let me get my screen share up. Good afternoon, everyone. I hope my screen is visible.
Yes, it is.
Okay, thank you so much. I apologize for the delay. I was facing some internet issues. So let's get started. I'm Ananya from Nitte Meenakshi Institute of Technology, Bangalore. And today I'll be presenting my paper, A Usability Evaluation of a Mixed Reality Cooking Assistant. So these are all the topics that we will be covering today. Let's start off with the introduction. So our application is a mixed reality cooking assistant. So I'd like to start off with a quick introduction on what mixed reality really is. So under the umbrella of extended reality, we have three broad categories: virtual reality, augmented reality, and mixed reality. So virtual reality is when the user is transported to a completely immersive environment. For example, virtual reality games that once you put on the headset, you can completely see a virtual world. Next, we have augmented reality. Now, this is where we overlay digital content onto the real world. A common example of this would be any shopping application, for example, Amazon or IKEA. In the case of IKEA, we're able to place our furniture virtually on top of our real world. So we can get an idea of how the furniture would look in our real, maybe living room. But the limitation with augmented reality is they're not really interactive. So you could pass your hand through it, you could walk through it, and nothing really happens. This is where mixed reality comes into the picture. Mixed reality goes a step further by integrating digital content with the real world and also making it interactive. So this enables you to do things like press a button on your virtual screen, or maybe move a virtual panel around, resize an object, etc. So this is what we've built, a mixed reality cooking assistant. So why did we build this? What is the problem we're aiming to solve? So all of our existing recipe sources, let it be physical cookbooks, follow along videos, or mobile applications, these things require users to repeatedly shift their attention away from the actual cooking task. This introduces hygiene issues, disruption of your workflow, increases cognitive load, etc. So what we thought of was to introduce a solution to solve all of these problems. So to start off with, we conducted a literature review, and the gaps that we found are as follows. There are many existing mobile augmented reality applications, but they require users to interact with handheld devices. This disrupts workflow. There are also projection-based and other basic AR systems, but these lack depth awareness and proper alignment with real-world kitchen environments. There are already existing MR systems as well, but they often rely on a single interaction mode and they do not fully integrate handless operation. Therefore, there is a need for a fully hands-free, spatially anchored, and multimodal MR cooking assistant. So the objectives that we hope to achieve while building this application were as follows. Number one, to develop a hands-free cooking assistant that would enable interaction without any physical contact. Number two, implement spatially anchored guidance. So what we mean by this is to align any cooking instruction on top of real-world kitchen objects. Number three, integrate multimodal reaction, that is voice-based, gesture-based, and controller-based inputs, providing flexibility. Number four, to conduct a user study in real-world cooking conditions and assess interaction, usability, etc. So our solution to the problem mentioned below are as follows. We tried to implement three major things. Number one, spatial anchors. This includes portraying instructions right on top of real-world objects. This is also the novelty of our application, something called spatial anchors, which I will dive further into in the future slides. Number two, step-by-step instructions that makes the cooking flow very easy and simple to follow. And number three, hands-free interaction. As we all know, while cooking, it's not really possible for us to hold a controller or a device, which is why we've introduced three modes of interaction, making it completely hands-free. So in the interest of time, I'll do a quick run through of the system design and dive deeper into the actual workflow. So for the front end, we've used the Unity UI. For the MR integration layer, which is the most important part of our project, we've used something called pass-through rendering. This enables us to put on the headset and still see our real world. For the spatial anchors, we've used the spatial mapping Unity module. And for the interaction module, for voice commands, we've used Wit AI. And for the instructions to be displayed step by step in every scene, we've used the instruction system. Now, to the most interesting part, the workflow. So in our workflow, we have two phases. So this is how a user would actually use our application. First, the user would put on the MetaQuest headset in their real kitchen. They would then enter the recipe selection screen and select a recipe of their choosing. After checking that they have all the ingredients required, they would enter the setup mode. This is where we've used something called spatial anchors. Spatial anchors capture real-world 3D coordinates. So what this enables us to do is place any cooking instruction right on top of your stove or your chopping board or your wash basin. So based on the recipe selected, the user will be prompted to select various cooking locations. So to give an example, let's say I was preparing a sandwich. I would have to wash my vegetables in the wash basin, chop my vegetables at the chopping board, and a grill to grill my sandwich. So in my setup mode, I would have to physically place an anchor at these three locations. So I would go up to my chopping board and place an anchor. This location is now stored. and any instruction that would require me to use my chopping board would be placed right on top of my chopping board. So essentially, whatever cooking step I'm on, all I would have to do is look up and I would see the cooking instruction that I have to do and I'd go about my cooking. This minimizes attention shift, cognitive load, especially for someone who is very new to cooking. This is highly helpful. From here on, each cooking step is displayed at the specific or anchor location with audio narration. Now, to make our application truly hands-free, we have 3 modes of interaction. One is using the MetaQuest controller. Number 2, we have gesture-based interaction. Number 3, we have voice commands like next, repeat, and back. This would be much easier looking at the screenshots that I will be showing right at the end. So with this application built, we conducted a user study with 21 participants aged between 18 to 40. The participants filled a 10-item Likert scale questionnaire evaluating key usability and interaction parameters on a scale of 1 to 5. So as we can see, 96% found the interaction highly reliable. That is the 3 different modes of interaction. 82% found the audio instructions really clear. 83% found the interface intuitive, and 73% reported accurate spatial alignment. So to conclude, what we've done is successfully built and tested our application in real-world cooking scenarios. And with the user testing, we have demonstrated the practical applicability of our application. All of our users had good responses about the usability and reliability. We've made the application truly hands-free, enabling seamless interaction using voice, gestures, and controllers, providing context-aware, real-time cooking assistance. According to all of our users, this has given them an improved new cooking experience. For our future work, we aim to touch up areas of adaptability, interaction robustness, and scalability. So one thing that we wanted to implement is, as we know, our kitchen is not always one specific environment. The noise levels, the lighting levels, the space, all of this are varied. So we would like to test this out in various different environments. Number 2, instead of static step-based guidance, we would like to integrate adaptive instruction flows based on user progress. Number 3, improve spatial anchor stability. In our user study, 73% were satisfied with this particular aspect, so we intend to improve on it. And number 4, something that we've noticed is in highly noisy environments, the voice commands sometimes do not always work. So that is something we would like to improve on in the future. So coming to the actual screenshots. So as I mentioned, once you put on the headset, the user can see.
Excuse me. I'm sorry to interrupt. You have like less than a minute left.
Okay, I'm almost done. Thank you. So we would choose a recipe over here. So this is a real world that we can see in our headset, as well as the virtual panel that's set up here. So this is a setup space. It says shopping board. And here I'm placing an anchor. So this location is now stored. So any instruction is placed at that particular place. So while I'm doing my cooking, I just have to look up and there's my instruction. Another way of interacting with it is through gestures. So I can physically press the button, even though it's virtual, I can press the button and it goes next. Or I can also pinch while pointing at it and I can go next. These are the multimodal interaction that we've implemented. There's also a link to the demo video, which as time permits, I will not be able to display, but I'd be happy to share this presentation with you. That is all for today. Thank you very much. I'm ready to take any questions that you have for me.
I don't have a question, but really interesting approach, and especially when you're using this type of the approaches and looking in the future is becoming more and more interactive in that way. So good work.
Thank you so much, sir.
Are there any questions from the chairs? All right, I believe in that case we can move on. We'll go to the next presentation now.
Thank you so much.
So next we have Tirupati Rao Dokara, who will be presenting Inverse Vertex Pyramid, IVP, a bottom-up metadata and policy-driven design pattern for scalable AI and data automation platforms. You may now begin your presentation.
Yeah, Tirupati Rao is not there. I'm co-author Pradeep here. Good evening, everyone. Hope you can see my screen.
Yes, we can.
Okay. Okay. Thank you for giving us this opportunity. Today we are presenting Inverse Vertex Pyramid. This is a bottom-up metadata-driven design pattern for scalable AI and data platforms. So today, when you see the evolution of enterprise architecture, it has moved from microservices to much modern. Microservices has been trending in the last few years, but we found some constraints adopting microservices kind of architecture, which is where this was born more out of need than anything else. As we move towards automation across customer service, risk, and supply chains, there is a critical bottleneck. There is always a constant struggle or tension between standardization and deep domain specialization, right? So this is where we try to come up with this strategy pattern where we can resolve some of these constraints. So as I said, most platforms are built top down, where teams build a generic stack and then customize it for different business units using code forks, integration glue, and bespoke microservices. What we have realized is this introduces something like called as a specialization tax. In other words, it's also you can say accumulated technical debt that accumulates or scales non-linearly with the number of use cases. The more you try to specialize, the technical debt increases exponentially, and at some point you have to completely refactor, and the code becomes brittle and fragmented, as well as governance becomes a big nightmare when you're trying to adapt it for regulated in domains like insurance, banking, so on and so forth. So what is it that we have done, right? So it starts with what we call as the use case vertex, which is narrowing down on what is the deep domain high value automation scenario. Example, if you're taking insurance, it is, if it's regulated claims can be an example. What we do is we extract reusable invariants and variability parameters into actionable descriptors, and those descriptors are what we configure as metadata models, ontologies, or policies is what it is configured, and that is that is very contextual and specific to the domain. By externalizing this variability, we ensure that the new variants, like if it has to be adapted to a different geography, or if it has to be, if the business rules changes, then the new set of business rules are adapted through configuration rather than code rewrites. Moving to the 6 principles of inverse vertex pyramid architecture. As I said, we follow the principle of use case primacy, where every capability must be justified by a real business need. We maintain a stable execution plane that changes only when the capability gap is identified. As I said, it is descriptor first. wherein variability must be versioned in the descriptors before any custom code is introduced. If you look at principles 4 and 5, right, it focuses more on control plane compilation and policy by construction, ensuring that the compliance related aspects are baked into the process, and it is managed through configuration as opposed to code changes. And you obviously have feedback to measure drift and data lineage, data drift, model drift, and all are baked into in the form of feedback loops where constantly all the metrics are captured and then given as feedback to the uh, to the you can say the descriptors or the control plane where the policies are defined. What happens when we split the control plane from the execution plane is there is a logical separation where control plane demonstrates intent and validation, where all the runtime components are maintained as part of the execution plane. The control plane responsibilities, if you look at it, it validates descriptor consistency, evaluates policy constraints, and compiles descriptors into deployable artifacts like pipeline manifests and access rules. Whereas the execution plane remains a deterministic runtime engine for model serving, training pipelines, and workflow orchestration, which uses substrates like Kubernetes that can carry the execution plane components. Descriptors, as you can see, are not just limited to documentation, they are executable signals. As I said, we have 5 types of descriptors. One is metadata models, which maintain the data contracts, the schemas, data lineage, and data semantics. Then you have domain-specific ontologies that maintain domain-specific configuration, entity relationships, interoperability mapping, so on and so forth. And then you have policy descriptors that take care of your risk, privacy, retention, access control that can all be configured as policy as a code. And then you have workflow templates that can bake in your decision graphs, human in the loop, wherever you need a high degree of accuracy and low tolerance for failure. You can also bake in human in the loop as well for failure for redressal. This is the comparison of the different architecture templates. As you can see, it is not meant to be a replacement to any of the existing templates. Many times it is hybrid architecture as well. But as I said, it addresses some of the constraints where for example, in case of microservices-based architecture, variability usually leaks into the code, and uh, duplicate policies often get duplicated across the different microservices and things like that. Whereas in case of IVP, it is prepared or designed for change. The locus is of variability is addressed through configuration and policy parameters. This prevents distributed sprawl and ensures that there is consistency across governance and compliance related policies. So from specialization, while other principles go from generalization to specialization, how do we generalize some of these policies that we have configured? We operationalize generalization through a 6-step process: capture, mine, model, author, compile, and execute. The gap analysis or the mining gap that we address, where the platform cannot support an existing use case, is also identified and addressed through domain deltas that we call as domain deltas. It's again it's modeled separately, and if at all it has to be baked into the configuration, it is put into the control plane where the model deltas are addressed through configuration.
Excuse me, I'm so sorry to interrupt. You have a minute left.
Okay. This is where we have taken an example of claims, first notification of loss claims in the insurance domain, where if you look at an insurance domain where an insurer is operating across multiple jurisdictions, say Germany or US, Germany and US, instead of forking pipelines for Germany or US, what we can do is we can introduce a YAML configuration profile that specifies jurisdiction-based schema, jurisdiction contracts, retention policies, fraud thresholds, and all that can be set in the configuration file. The core platform thus remains unchanged, whereas the control plane compiles the specific rules into the runtime. So it is achieved during runtime. The geo-specific compliance rules are taken. Lastly, what are the metrics that we capture? Configure to code ratio, core stability index. The empirical goal is we expect to see higher CCR and CSI as the use case portfolio expands. As we said, we experimented with a small couple of use cases, but we believe that this has wider scope across industries and across domain as well. Final thoughts. IVP provides a governance by construction approach that is essential for compliance with frameworks like GDPR, EU AI Act, where AI policies, as they get stringent and more governance oriented, this kind of framework can help easing the design complexities and simplify the design for the engineering teams. Thank you so much.
Hello. Yeah, it was really a nice presentation. Just tell me, is it the framework that you have proposed for this automation?
Sorry, ma'am, can you repeat that question?
Exactly, it is the framework. It is the framework that you have proposed for this automation.
Correct. So we have actually adapted it in our engineering practices as well in our organization where we are doing AI platforms and products. When we faced bottlenecks with other architectures like microservices, we adapted this and we have been able to successfully use it in some of our domain-specific use cases.
Okay. What exactly the input to this? Can you please represent?
We are from Scientific. We have this Scientific AI Data Foundry that is a single pane of glass for bringing together your models, your data, your infra, all of it in a and also build pipelines for orchestrating all these components. Wherever we have had to build domain-specific use cases, we have used this framework. This is our proprietary. We have created this as a proprietary thing for our engineering teams.
I don't have no questions. Good work. I like the bottleneck approach. It's always practical, so good work.
Thank you. Thank you.
All right. Next, we will have Aman Pathak, who will be presenting memory security from cold boot attacks to side channel defenses. You may now begin.
Am I audible?
Yes, you are.
Okay. Good evening, everyone. I am Aman Pathak, and today I'll be talking about memory security, specifically the threats that target the path between a CPU and a main memory, and what we can actually do about them. So the paper is outlined like this. We will start with why memory encryption is necessary, then go through the main threat categories, which is cold boot attacks, bus sniffing, and side channel attacks. Along with, we will cover how Intel and AMD have responded in hardware, how integrity is protected using Merkle trees, and how granular encryption handles multi-tenant cloud environments. We'll finish with summary and open challenges. So the starting point for this paper is a gap that doesn't get enough attention. People think about encryption and immediately think of disk encryption, but that only protects data which is at rest. The moment the system boots and loads data into DRAM, that data is sitting in memory as plain text. And the CPU DRAM interface has no cryptographic protection in the standard at all. In the paper, we review 4 concrete ways an attacker can exploit this. Whole boot attacks, which exploit the fact that DRAM cells briefly retain their charge after power is cut. Bus sniffing, where someone physically intercepts the DDR traces between the processor and the memory module. Side channel attacks, which recover secrets from the power consumption and timing measurements. And address pattern leakage, where you can infer what a program is doing just by watching which memory address it accesses, even without reading the data itself. The design challenge is generally very tight here. Any solution which is found has to be completely transparent to software, has to keep pace with DDR memory bandwidth, and has to fit inside the sub 2 nanosecond latency window of DDR4 and DDR5 memory. So I'll begin with cold boot attacks. Cold boot attacks have been known since 2008, but our survey shows that they are still highly effective. The underlying physics is quite simple. DRAM capacitors don't discharge the moment we cut the power to them. At room temperature, we have tens of milliseconds. If we cool the module down, then we can stretch that to several minutes. The attack is power cycle or physically remove the DIMM, move it to an attacker controlled machine, boot a minimal OS from USB, and dump whatever is still retained in the memory. What the literature shows is that this works across all commodity DRAM generations. Bor et al. Demonstrated that DDR3 addresses scrambling falls, that the DDR3 address scrambling falls with only around 50 bytes of known plain text. Patterson showed that the NTRU private key recovery from a noisy DRAM image is quite possible. Hilger showed that Android phones expose encryption keys during a warm reboot. And non-volatile caches are arguably very worse because they are designed not to lose data. No single countermeasure is sufficient here. The paper recommends a layered approach, inline AES XTS encryption with keys stored with the keys stored on die e-fuses that physically vanish at power off. Per page key eviction on suspend or VM switch, boot time scrubbing at post, a TPM 2.0 root of trust so secrets never reside inside the DRAM. Explicit flushing of non-volatile caches before shutdown is required. Even so, the residual gap remains. DMA descriptors and debug registers can sit outside the encryption boundary. Bus sniffing is the second class of the attack. The DDR bus carries no cryptographic provision in the standard. So anyone who inserts a logic analyzer or FPGA between the CPU and the CPU socket and the DIMM gets a passive feed of every memory transaction on the system, below any software or OS level control, and even inside a hardware enclave. The most striking example we will cover is that the membuster attack from Lee et al. In 2020. They showed that Intel XGS only protects data while it is on the on package cache. While when there is a last level cache miss, the data will travel unencrypted over the DDR4 memory. And crucially, we don't need to break the AES encryption. By simply timestamping the DRAM row activations, membuster reconstructs the enclave control flow from pure access patterns. The conclusion is very stark. An enclave is only as secure as its weakest off-link chip. The composite defense we identify is the only robust answer. On the software side, OS controlled XOR encryption before DRAM eviction and boot time page permutation, which achieves about 10 times lower overhead than full data encryption. On the hardware side, an AES XTS engine at the memory controller encrypts every 64-byte burst before it leaves the package. An address scrambler breaks spatial correlation at around 1% timing penalty, and dummy reads with QoS shims flatten observable bandwidth patterns. We will need all three together. This brings us to how Intel and AMD have actually put memory encryption into silicon, since these are the practical tools hardware engineers work with today. Intel TME, Total Memory Encryption, was introduced in the Ice Lake generation of the processors. It uses a single on-die AES XTS key that is invisible to the operating system. No driver changes are required and no OS patches are required. It encrypts all DRAM within 1% performance overhead. The limitation is clear. One key means you cannot isolate co-resident virtual machines from each other. Intel MKTME, which is the multi-key TME, addresses this directly. It adds a 4-bit key ID to the page table entry, giving up to 32 independent key slots. Each VM will get its own key, so a compromise in one tenant's address will not expose the another. The cost is that hypervisor has to manage the keys, and a key context switch stalls the data path for about 60 nanoseconds. AMD's approach is SME and SEV. SME uses C-bit in the page table entry for per-page selective encryption. SEV adds an ACID scope key cache on top, giving each VM a distinct key with inline rekeying on world switch. On Epic Milan, SEV adds only about 1.2 nanoseconds per 64-byte line. Overall, it will add around 3% overall. As the comparison table, you can see MKTME and SAV are currently the only architectures that deliver genuine multi-tenant isolation. Integrity protection. Encryption handles confidentiality, but it cannot tell you whether data has been tampered with. We also need integrity protection to detect bit-level corruption, stale data replay, where an attacker substitutes an old valid ciphertext, and operation resequencing. The dominant solution is the Merkle hash tree. You hash every cache line, combine hashes up a binary tree, and anchor the root in an on-die register inside trusted boundary. The baseline cost O log n hashes per verification, but it roughly doubles off-chip traffic, which is unacceptable at DDR speeds. The Bonsai Merkle tree from Rogers solves this by caching the upper tree level in on-die SRAM. That drops the DRAM hash overhead from around 12% to below to about 1%. For higher throughput, PAT uses parallel independent hash engines and commits to 64-byte lines every 2 cycles. HMT from Shadab Airtel fuses the Bonsai structure with SIMD SHA engines and subtree caching, achieving a 7 times bandwidth gain over software BMT while staying drop-in compatible. For replay-specific protections, TechTree attaches a monotonic counter to each line. TMSS uses version numbers, which is efficient for bulk invalidation at any VM teardown. So integrity protection. The engineering techniques make Merkle tree practical in production. A verification cache stores recent authentication paths in set associative structure. It achieves over 90% hit rates on server workloads, meaning most verifications never touch DRAM. Speculative writes allows provisional hashes to travel alongside the dirty data. A write will only commit after the hash recomputation confirms its integrity, hiding much of the latency. Lazy counter refresh updates counters only at eviction, cutting counter traffic by around 70% while still fully defeating the replay. The bar chart on this slide, which you can see from 12% overhead from the baseline tree down to sub 1% for BMT, HMT, and PAT. The main remaining challenges are largely DIMMs, increasing tree height, and worst case latency and competition for bandwidth in the inline AES engine.
Excuse me, I'm sorry to interrupt. You have 1 minute left.
I am also just a minute. Full memory encryption with single key is not sufficient for cloud environments. So the hardware mechanism are already discussed. MKTME is 32 key slots, AMD SME, C-bit, and SEV per VM key cache. For byte addressable non-volatile memory, the paper discusses 2 targeted schemes. NVM shelf uses CTR mode for hotline and ACP mode for cold lines, reducing the cell wear by around 31%. For STT-RAM, encrypting only the long retention banks improve end-to-end latency by 17 to 36% while protecting the data that survives the power loss. Side channel attacks will not break cryptography. They attack the physical implementation by exploiting leakage that was never intended to be observable. SPA recovers the algorithmic structure from a single power trace. If the AES key expansion has a different power signature from the data rounds, SPA can separate them and eventually recognize the key. At the circuit level, Ping Pong 128 runs dual complementary AES cores, so current draw is data dependent. Safe DRP equalizes FPGA LUT counts. Complement registers flatten the Hamming weight profiles by about 20 decibels. RRAM motifs use alternative cell polarities to separate differential pulse heights. Side channel defenses. The central finding from our side channel analysis is that defense layers are super additive. Masking alone helps, power balancing alone helps, but combining then pushes the signal to noise ratio below 30 decibels. That is a qualitative change in practical security. The best practice layered SoC design stacks 4 levels. that is Boolean and arithmetic masking at the base, epoch-based key rotation, dual core balancing with ping pong 128, and instruction shuffling with random delays at the top. This table summarizes the full picture. Cold boot attacks are addressed by inline AES XTS, key eviction, and a TPM vault at under 1% overhead. Bus sniffing by AES XTS, address scrambling, and timing noise at 1% penalty. Multi-tenant leakage by MKTME or SCV at 3 to 6%. Damper and replay by bonsai or HMT Merkle trees with lazy counters at less than 1% DRAM bandwidth.
Excuse me, your time is up. Please sum up.
Yeah, I'm sorry. So to wrap up, the memory encryption is practically a necessity. Cold boots, bus sniffing, and side channel attacks are really well documented. The framework in this paper which we address are confidentiality through TME, MKTME, SME, SEV, integrity through bonsai and HMT Merkle trees at below 1% bandwidth overhead, and side channel attacks are resisted through masking, rigging, and circuit hardening, pushing the signal to noise ratio below 30 decibels. Thank you. I'll be happy to take any questions.
Thank you, Aman. It was really a nice presentation with the encryption and all this parameter to evaluate it. So can you please tell Ki what exactly the challenges you face throughout your work?
Good evening, ma'am. Ma'am, the paper is a review paper, so we are actually reviewing the stuff provided by previous researchers. So there wasn't any technical challenges that we as an researchers faced in this review paper.
So, okay. So out of this, all these reviews that you have had, so what do you think, what it will be go for the future work? What can be taken out for the future work? What can be taken for the future work?
So in terms of future work, we can look at the heterogeneous computing environments with things like GPUs, accelerators, especially in the case of AI, like we have been using GPUs like non-stop. The memory system is no longer confined to just CPU and DRAM. Second is that the side channel evolution in newer architectures, like the review paper is quite dependent on the previous architectures of the CPU which have been presented in the market. RISC-V is a quite expanding domain, and we need some security for that too. Third is the better key management and generation. Right now, things are like limited key slots and over-reliance on existing hardware primitive are creating some constraints. So we need to design low-area hardware-based key generators, and that should be secure, not like Intel or AMD, which is like quite closed source. We need to push RISC-V to its brim, to its limits, and we have to produce open source hardware for that. Another important thing is that the compilers and the software-assisted security. We should not completely be reliant on hardware for security, but instead we should offload some of its work to the compilers, which can generate some certain code. The compiler can generate instructions which are inherently secure by nature. Finally, I would like to say that there is no essentially any standardized benchmarking framework for this. We need to develop some benchmarking framework which can essentially evaluate a system's security, how much secure it is against these memory attacks.
Okay, Amma. Thank you.
Interesting work from me. I really like the approach into the memory concepts and talking about the security that goes with that. So keep working on that, and it will be nice to see some empirical results in the future on this work.
Thank you.
All right. Now we'll circle back to the presentations that had been missed previously. Just one moment. Okay, so first up we'll have Arya Sagar Sanavane. Is Arya present today? Or any of her co-authors? All right, in that case we'll move on. Next we have Anjan Babuji, who will be presenting an
Yes, madam. I am Dr. Ravi Kumar in place of Anjan Babu. I am one of my co-authors, madam. I want to project.
All right, you may now begin with your presentation.
Okay, okay, madam. So this is my presentation. My paper ID is 725. So my title is an agentic AI-based framework for crop production analysis using agroclimate and soil parameters. So this is my presentation outline, introduction, objectives, literature, and like that. So mainly, my work is used in the agriculture field for crop production data analysis. We are applied. So actually nowadays, recently, machine learning, artificial have enabled data-driven approaches for agricultural analytics like predictive performance or production analysis, crop yield detection using statistical models. But most of the existing approaches depend on statistical prediction models. That models lack adaptability and autonomous intelligence. So that's why we are proposed the agentic AI framework, which combine our agentic AI framework combine machine learning models with autonomous agents capable of perception, reasoning, decision making, and have recently assigned a greater attention for a promising solution to these challenges. So, by enabling adaptive data pre-processing, intelligent model selection, performance-based decision making, so agentic AI systems can significantly enhance predictive accuracy and robustness. So, these are the objectives of our paper. The main objectives of our study are to develop an intelligent agent-driven framework for crop production analysis, to analyze the influence of agroclimate and soil parameters on crop yield production. So to implementing and compare our models, linear regression, random forest, and CNN LSTM models. So one more to after apply the models to evaluate model performance using RMS root mean square error, mean absolute error, and R square difference metrics applies. After that, we are identifying the most reliable predictive model for accurate crop production estimates. So these are the our paper objectives. So these are the literature we are identifies. Mainly, all existing literatures are statistical regression techniques, ML, machine learning, individually deep learning, random forest, multi-agent systems are there. But we are identifying a research gap based on this above existing literature. We are proposing agentic AI plus machine learning, deep learning for this agroclimate data set. So these are the research gap we are identifies. So these limitations, our study proposes an integrated agentic AI based framework that automatically manages data pre-processing, model training, evaluation, and decision making while comparing the traditional ensemble and deep learning models for crop production analysis. So these are the research gap we are identifies based on the existing available literature. Next, methodology. So we are using this, implementing this agentic AI and machine learning, deep learning for crop yield production. The main algorithm, these are the algorithm we are apply this one. First, initially load the crop production data. Next, initialize data pre-processing agent. This pre-processing agent mainly to perform the pre-processing of the data set, like to overcoming the errors, noise, missing value. All this overcomes through this agent, and also performing feature engineering for selecting the relevant features, subset of features required for processing. This agent do the pre-processing stage like a cleaning to overcome the missing value, and as well as some data conversion technique. So some suitable format not there. We will using the models are converting categorical numerical only taking categorical that not present. So we're converting to the label encoder. Feature engineering all perform in the pre-processing agent. So after pre-processing this all data set to overcome the what was the all mistakes, misuse, and one format, other format after pre-processing, next training the models. In this models, we have applied the three models: linear regression, random forest, and LSTM models were applies. So individually applies the linear regression, random forest too, and LSTM model where applies. After that, we are evaluating the training models. Next agent, initialize decision agent to this decision agent to compare the performance metrics, selecting the best performing model and use it to these models predict a crop production and finally visualize the results. This is the overall algorithm of our research. And mainly, we are proposing to the agentic AI framework. This framework, our agentic AI framework, composed of multiple autonomous AI agents. So these are follows: data pre already covered in the algorithm, data pre-processing agent to model selection agent to evaluation agent to decision agent. So data pre-processing agent already cleaning, transform, extraction the data. Model multiple predictive models are used for performing this prediction, and after that evaluate agent to evaluate the performance using the predefined metrics, and finally select the decision agent to best optimal model for crop production data set taking of it. This is our agentic framework. And next models linear regression. So already you know it linear regression. Simply it is a to perform a prediction using a dependent variable, independent variables. We have a lot of variables are there. Y is the dependent variable, X is the independent variable. So we are performing linear regression model. It is, but we are applying the multiple single multiple linear MLR technique we have applied. And one more model, random forest is a ensemble classification technique. It can building number of decision trees are there, constructing a number of decision trees with bootstrap aggregating, and finally make the predictions based on the majority, aggregating all predictions, which is the majority, then predicting the random forest is a ensemble classification technique for building constructing number of decision trees and finally aggregating the all decision trees with majority. And one more algorithm, LSTM, long short-term memory. It is a deep learning technique. So this using in this LSTM mainly used for extension of recurrent neural networks. So because it is used for the temporal data, sequential data, because the intermediate nodes not remember the value. That's why short-term memory use cell mainly for input data and based on the gate values, input gate and one more called output gate, one more rejection gate. Three gates are there. Apply the hidden layers, number of hidden layers are there, and finally next stage we are passing the value one node to other node using like a neural network. It is like a neural networks model. Input layer, output layer, hidden layers are there. In the hidden layer, remembering the state to use the memory cell as the main technique in the LSTM. So
Excuse
these are
me.
the
I'm sorry to interrupt. You have 1 minute left.
okay, thank you. And finally, we have conducted the experimental results. Actually, our entire experiment is evaluated using the crop production data set taken from the Kaggle dataset, which includes the state-wise, district level agriculture records are there. This study mainly detailed on agriculture production data with several Indian states and districts are there, overall country-wise data. It includes 10 attributes are there, and for nearly 50 instances are there for entire data like a geographical, climatic aspects and affect the output. So data sheet contains the attributes, climate, like soil parameters, temperature, humidity, soil, like that. And these are we are implementing the Python language and some machine learning libraries, deep learning libraries, PyTorch are used for implementing these models. So these are the performance. We have compared the three models: linear regression, random forest, and LSTM models. So root mean square error, mean absolute error, and R square error we are find out it based on this above metrics. We have obtained the random forest is the low RMSE values. This compared to linear regression 2.64 is there, but LSTM 2.15 is there. So we have taking the root mean square error. So for these errors are find out to actual value to predicted values are compared, and which is the smallest RMSE or R square value, we take the better model. So according these three models, apply the agriculture data set, random forest having the least RMSC, MAE and values, and somewhat better than for LSTM. Actually, our main intention is predicting the LSTM model, but based on the some parameters not optimized. That's why accuracy still we want to main. Our intention is implementing the LSTM model for agentic AI based, but still some work was going on. So that's why we are not optimizing the parameters low, but better than to the linear regression. So random forest is the best
Excuse
approach,
me.
madam.
Your time is up actually.
Okay, ma'am. Okay, ma'am. So finally, a conclusion. Ma'am. So we are given the conclusion for this overall through the compared evaluation of the we are performing the linear regression CNN and random forest too, but achieving the highest accuracy in the random forest model and minimize the R square error. So this proposed framework completely used for the crop production forecasting. In the future work, focused on real time weather data, satellite imagery, reinforcement techniques are applied for enhancing the accuracy and decision support system. Ma'am. Thank you for this. Ma'am. Sir.
Thank you, Ravi Kumar sir, for the
Madam, yes, madam.
presentation.
Yes, madam.
I have just one question.
Okay, madam.
It is a kind of prediction that you have done
Yes, madam.
using three models:
Yes, madam.
linear regression, random forest, and
Forest.
LSTM.
Yes, madam.
Linear regression is very basic machine
Prediction,
learning.
madam. Yes, madam.
Linear regression is very basic machine learning model.
Yes, madam.
Random forest is for classification rather for the
Classification.
prediction.
But random forest both using regression as well as
Yes.
classification.
Yes. But it is generally it's for
Generally class. Yes,
classification.
madam. Yes, madam.
And you have used deep learning model,
Yes, madam.
that is LSTM, which
LSTM.
is used for the again prediction, LSTM.
Yes, madam. Yes, madam.
And you are claiming that random forest is working well
Yes, madam.
than the
Other
linear
12.
regression. Both of them.
And
Both
LSTM.
of them. It is working well than the both of them. No?
Yes, madam.
Yes. So it is quite obvious that the random forest is performing better than the linear regression.
Yes, madam.
But how it is performing not how it's performing well than the LSTM, deep learning?
Actually, our intention may LSTM, madam. But because some parameters we will optimize, madam, LSTM. Number of parameters are there. We are not optimizing the like a gradient descent techniques and also tangent function, sigmoid function. We are not optimizing. That's why I think more error is there. Means in the future we will overcome that, madam. Actually, our intention, main intention, LSTM only getting highest accuracy, madam.
Okay. And
But
one
due
more
to the
question.
yes,
And then the random forest, what number of decision tree that is being used to get the better result?
yes, madam. Yes, madam.
How many decision trees will there?
Okay, depth means we are optimizing the decision trees nearly based on the data sheet, partition to I think I have applied the 10 decision trees, 10 decision trees, and taken the majority of the individual data sheet, like a bootstrap aggregating. We are divide the data sheet into 10 equal parts. So each data set applied to this one, and finally taking the majority, 10 random 10 decision trees applies.
10 decision.
Yes,
so have you done any kind of comparison with number of decision tree, and you find that 10 number of decision trees giving the better result?
That is that comparison. We are comparing only this LSTM and random regression, linear regression.
So that means
yes.
Are there any other questions from the chairs?
No question from me.
All right. Now we'll move on to the next presentation. Is Anil Kumar Bandani present here, or any of his co-authors? All right. So then we'll move on. Is Suman Kumar Mandal present?
Yes, ma'am.
All right, so now we have Suman Kumar Mandal who will be presenting early blindness stage diagnosis using a fully connected neural network architecture.
Yes,
You may
sure,
now
ma'am.
begin.
Okay, thank you so much, ma'am. Just a minute. Is it visible, my presentation?
Yes, it is.
Okay, thank you so much, ma'am. Today I'm going to presenting my paper, Early Blindness Stage Diagnosis Using Fully Connected Neural Network Architecture. This is my paper ID is 92. First of all, today I told you the introduction, the IOP, intraocular pressure measurement, which is the one of the main risk factor for the glaucoma. Early monitoring can identify pressure changes before optic nerve damage occurs. And optic nerve fed and retinal nerve fiber layer analysis using the OCT, that means optical coherence tomography. Early structural changes in the optic disc and thinning of RNFL can be detected even before the vision loss. Here I have detecting here, this is the RNFL. Significance of this study: early diagnosis of glaucoma is critical because vision loss caused by the disease irreversible. Detecting glaucoma at initial stage allow the timely intervention to prevent slow down optic nerve damage. Here I have the this slow down optic nerve damage. Here I mentioned this is from this image. Now, most of the thing the objective, this work aim to developing and testing the fully connected neural network model based on the ResNet 50 to classify early stage glaucoma as one consisting the retinal glaucoma, that's the RG, and non-retinal glaucoma. It is the binary classification problem. So state of that, first, data quality and standardization. The data quality and standardization remain major issue due to, and actually it was the challenges part. The major issue due to the variation in the imaging device lighting condition and acquisition protocol, which affected the model accuracy. Insufficient annotated dataset. The lack of sufficiently annotated dataset restricted supervised model training and validation, leading to based or the inconsistent outcome. Model robustness and generalizability. Model robustness and generalizability as model trained on the specific dataset often perform poorly on unseen or real world data. Integration of multimodal data, such as the combining fundus image, OCT scan images, and patient clinical record in underexplored yet essentially for improving diagnosis, precision, and early disease detection. This is the literacy review. So next I will go ahead. This is the methodology part, but this is the actual the implementation part that I have used in our paper. Actually, first we have applied the ResNet 50 model. It is the existing pretend model I have applied. First of all, actually we will the collected the data set. Actually I have collecting the data set is the OCT data, OCT images, ACRIMA data set. Original data set samples were the approx 975. After removing the noise, data samples amount are 811, where the training under the RGB class and energy class approx 564, and validation and for the validation set under the RG and energy class the 142, and similarly the from the test set RG and energy class on the 104 is the sample. So actually computed the ResNet 50. So first of all we must be record the data resizing. All input images must be converted into a same image size. Here we have applied the 224 cross 224 dimensions, and here the hyperparameter that is set by the human. So here we have mentioned the base size is 32, while the best sizing impact model convergence and generalization. Now next we have applied the data normalization approach. So why should we use the data normalization? Basically it is used the scale them into similar range between 0 and 1. Pixel value is divided by the 225 because 225 is the highest decimal value factor. So here we have applied the mean max normalization from. Now next we have applied the data augmentation process. So and data regularization. Here the data augmentation is the increase the data diversity like rotation, zooming, flipping, and here we have applied the only rotation and flipping. Actually it prevents the overfitting. Model become more generalization. In other words, you can say that aggregation augmentation is increase the size of the training samples, which enhance the model accuracy. So now after that completing the pre-processing step, and we have applied the ResNet 50 model for the training process. So here you have applied that ResNet 50, it is means the residual network. So 50 means a total number of ResNet under the ResNet model, total number is the 50. First 48 layer is the convolution layer, and one layer is the max pooling layer, and another one layer is the average pooling layer. Max pooling layer, that means selected the maximum value from the region. Region means it is the matrix. And also the average pooling layer, it is the calculated the mean value from this region. Now, actually, ResNet is the skip connection to train the very deep network. For that reason, we have applied the ResNet 50 model. And first of all, the convolution. Convolution, basically, it is the mathematical operation. And why the convolution layer? Because of that convolution means the extracted features like that local parameter, that is the age, shape, structure. So layer by layer, for that reason we so called that it is the convolutional layer. And layer extracted the features will be the how to the extract the features. Extracted the features by the kernel, or you can say the filter also. So kernel or filter, it is the small matrix just only, and to use the detect the specific pattern in specific pattern, like that size is the matrix font maybe 2 cross 2, 4 cross 4, 8 cross 8, 16 cross 16, whatever. And after that apply this model in a training data sample. So more than training data sample on the 811 training data samples total. After the completed the training data sample, we are calculating the accuracy and loss graph. And after the calculated actually we will the calculated the confusion matrix and the ROC curve, also the just a minute, also the analysis and conclusion, where will be the class, actually the classification of report, that will be the calculated from this confusion matrix. So classification report, first of all the accuracy overall the correctness, actually true positive plus true negative divided by true positive plus true negative, true false positive plus false negative. And now next the precision will be the compiled the first were trained the only 10 epochs, and after compilation 10 epochs will be executed the result and compare with the 20 epochs. So it will be the predicted both 10 and 12. So I will be the mentioned in a table all the values. So first, after completing the 10 epochs, the precision value from the energy non-retinal glaucoma. So precision value is the 0.78 and recall value is 0.90. F1 score is the 0.84. And from the RG class 0.91 and 0.80 and 0.85. First of all, the precision. Actually, precision is the correct positive prediction from the correct positive prediction, and recall, or you can say the sensitivity. How many calculate the positive are detected? Most of case is thinking this how many actual positive are detected, and F1 it is the balances between precision and recall.
Excuse me, you have about 1 minute left.
Okay, ma'am. Just a minute. And also we have applied the do one thing. First of all, we have applied the activation function. Here we have applied the activation function is the softmax, but you can also apply the sigmoid activation function. But I have applied the softmax activation function. Softmax activation function convert the output into probabilities into that sum to 1 across all classes. And why use the activation function in a deep learning model? Basically it is applied for the activation function is applied for the output of a neuron, enabling the model to learn and representation complex data pattern. If you are not use the activation function, so DNA just simple behave the linear regression. For that reason we have applied the activation function. And now we have applied the ROC curve also. Why use the ROC curve? Basically ROC and AUC, ROC curve show that true positive versus false positive, and AUC it measure how well the model separated class. And the optimizer, here we have applied the optimizer is the Adam optimizer. Basically Adam optimizer, it is used very flexible, because of that adjust the learning rate in a training learning process time, automatically adjusted learning rate. That's all I have applied. And this is the pixel value after executing the model, and it will be the perform. So first of all, we have the predicted. I have also provided the RG class, and confidentially will be the predicted 0.6 and also RG class, and we have predicted the 0.75. F1 score is the 84% and overall accuracy is the 75%. And here we have applied the future work. This for this data set we can be applied the mix up and cut mix also, or you can say the advanced level stage you can be applied the GAN based style GAN that we can be applied. This is all the reference. Thank you for.
Thank you so much, Kumar. Am I audible?
Yes, ma'am. Yeah.
Yeah. So it was really a detailed presentation. It's quite interesting also, and it is observed that you have done the work in a very detailed way, so that you knew the very bit of every steps of this research work.
Okay, thank you
Anyway,
so much.
so can you just tell me? Just I have only one query.
Yes, ma'am.
So what is the challenges in this model that you have used?
Right, ma'am. Actually, we are collecting the secondary dataset ACRIMA. From this dataset, actually, original image sample size was approximately 975. So, noisy data, that means unwanted pixel are included in a image. And on second one thing, that this is a small data set, so it is not the flexible in the real world scenario can be the applied in particular this algorithm. And
Okay.
this is my challenges.
So as you mentioned, the data set is very small, and you have applied the deep learning model. And
Yeah.
as we all know, the deep learning model is basically used for when you have a large data set. So
Yeah,
how do
yeah,
you mitigate
definitely.
these challenges over here?
Yes, ma'am. Actually,
So how have you addressed these challenges?
But first of all, we have applied the actually first of all we have applied the BGG 19, but it is not the flexible for this particular data set, because getting the accuracy approx the 72 to 75. Then we move on the next ResNet 50, because it is the light and deeply will be the actually we have applied our ResNet 50 can be used the skip connection. So because that the gradient descent value, avoid the gradient descent value, for that the flexible reason we have been applied the ResNet 50 model.
Okay. Have you heard the model about efficient net?
Yeah,
Efficient
that
net.
means efficient. Yes, ma'am. Efficient net. It is the lightweight from the ResNet 50, but
Yeah.
basically it will be used for the more complex pattern.
Okay. Okay. Okay, Suman. Thank you.
Thank you so much, ma'am. Thank you.
Are there any other questions from the judges?
Just great work, interesting applications here, and pretty well outlined concept. So good work on the research.
Thank you so much, sir. Thank you.
All right, that was our last presentation for today. And with that, we move towards the closing remarks. So I sincerely thank our authors for their excellent presentations and contribution in this session, and all of the participants for being a part of this international conference. I hope this session was informative for everyone, and on behalf of the entire team, I thank you for your support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters will be getting their digital certificates through email within the next 2 working days, and the publication should be live within 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. Before we conclude, I would just like to thank our session chairs for today. I would like to thank Dr. Minaki Roth and Dr. Iosep Gabriela, and I would like to present a token of our appreciation on behalf of Team ICTIS 2026 and the Global Knowledge Research Foundation and partners. Thank you so much for your valuable presence, chairs. And before we end the session, I would like to request everyone to please turn on their cameras for a virtual snapshot. Just one moment.
Hey, Elisa, is that done?
It appears that one of our presenters has just joined. We will be taking their presentation, but you might have to wrap it up a little quick as we are over time. So Arya Sanavne, I do request you to please start sharing.
Okay. লিপি করেছেন নাকি ম্যাম ব্যাস একদম
So hello, ma'am, can you hear me?
Yes, we can.
Okay, so I'm going to start my presentation. So first of all, I would like to clear our presentation, our project name. So our project name is AI ML based powered crop yield prediction system. Okay, so I'm going to start my presentation. So we have mainly seen that in agriculture, basically farmers have issue predicting the complete yield that they need in the system. This project AIML based powered crop yield prediction system aims to assist farmers to make data-driven decisions for selecting the suitable crops, fertilizers, and improving yield. So our system uses ML algorithms to predict the suitable crops, fertilizers, and to improve the yield of the crops. It uses a real-time sensor data, and it also uses the electronic components as well. This system enables a precision farming system. It also has efficient resource utilization and climate resilient agriculture. This integrates electronics, communication, AI, ML as a role in ENTC and in smart agriculture. So the meteorology overview, the data is basically collected from the IoT sensors. It also measures the soil nutrients and the environmental parameters like the NPK value, temperature, nitrogen, potassium, phosphorus, the soil moisture, as well as the humidity. It then the input values are pre-processed. The data is cleaned, and we can do the analysis based on that. Then we identify the key parameters, and then we then we use the ML models like logistic regression and random forest for classification. We get the accuracy and the confusion matrix, and based on these two models, random forest is the best model which we got. So what we have used is Python. For backend we have used is Flask. Then for front end we have used React.js and NPK7-in-1 sensors. Then the ESP module, the RS485 module for the communication. So here is a basic methodology and a block diagram. So what we have used is the sensors, and we have collected the data. After making the appropriate connection, we have used the ThinkSpeak for collecting the data and for a further pre-processing, and then we have applied the ML models based on the data, with which we have done three things: basically stage-wise crop prediction, fertilizer prediction, and crop recommendation. So here is the data based on the ML model. So as we have seen that the logistic regression has an accuracy of 90%, and random forest has an accuracy of 96%. As the random forest model performs better on nonlinear data, so we have used random forest in our project. So this results in feasibility for ML for crop recommendations. Also, we have compared the outputs based on the ICR guideline. So the second thing we have done is fertilizer recommendation. For the fertilizer recommendation, we have also used random forest, with which the accuracy is also 96%. Then we have done is the yield prediction. We have used a gradient boosting regressor, which has an accuracy of 95%. It highly elevates the nonlinear data between environmental and the social parameters. So it displays the NPK values, humidity, temperature, and it predicts the yield of the crop. So results validate the feasibility of ML for yield prediction. The outputs are validated also according to the ICR guideline. So this is the main output of the website we had designed. So we have taken the input values with which we have estimated the yield, and we have also estimated its category, which has low, medium, and high. And here we have done is a crop recommendation. And for crop recommendation, we have input the values which we got by our electronic components, and hence the recommended crop is there. And here we have done is fertilizer recommendation. And for fertilizer recommendation, we can use the same values used for yield. And here the recommended fertilizer is given as an output. As for the conclusion, this system successfully recommends crops and fertilizers based on environmental and soil parameters. It also predicts the yields of an crop. After this project, what we have seen is that the random forest performs better than the logistic regression with 96% of accuracy. This project demonstrates high effective integration of IoT, AI, ENTC for agriculture for innovation. As we have seen that in India, more than 50% are farmers. So I think this is highly recommended for farmers to use in their day-to-day lives in their farms. It lays a foundation for yield forecasting, fertilizer recommendation, and we can also do disease prediction in the future stages. It promotes sustainable farming and data-driven decisions making among farmers. So, thank you. Any questions?
Thank you, Aryan. Am I audible?
Yes, ma'am. You're audible.
I have one question. That at the beginning you told that the data set that has been collected from the sensor. So is that you or your team has been employed sensors to collect the data?
Actually, ma'am, we have our kit. We have our kit, so we have
Just tell me the data
designed
set
a
is
system.
available or it is you collected?
No, ma'am. Actually, we have not connected it, but actually this was a previous project and we have continued it.
Even though it is in the previous project, the data has been collected by you all or
Yes, data has
your
been
team?
collected by all.
Achha. Okay, so that means you have utilized the sensor over any of the area of your place?
Yes, ma'am. Actually, my father owns a farm in Zezuri area, so we have tried it there. I
What
also
kind of
have
crops
been
has been
photograph.
what kind of crops has been cultivated over there?
Okay, ma'am, we have tried using it on chili data.
Okay. Okay then. Thank you. You have done a good work. Try to focus into for the future work of it. Thank you.
Okay. Thank you, ma'am.
All right, so that was our final presentation for today. And as we have previously concluded, I would like to just say again, thank you so much on behalf of the entire team of ICTIS Thailand 2026. Thank you so much for tuning in, everyone. And with that, we will end today's session.
Madam, any possibility there, madam, our recording, madam?
Sorry?
Our recording, madam, actually at the time, any record is that you are all recorded presentation. That
Yes,
possible to share me.
just 1 second, I'll confirm about that.
Okay, madam. My paper is 750, madam.
All right, so I have been informed that the recording should be available within 7 to 8 working days.
Okay, madam.
All right.
Thank you. Thank you, madam. Thank you.
Thank you so much, everyone. The session is now adjourned.